Alright, today what we're going to do is learn about stoichiometry. And stoichiometry is essentially a fancy word for just doing triple T problems. So to review, we've done 1T problems, which are going from mole to something, or something to mole. We've done 2T problems, where you're going something to something, where the somethings can mean grams, liters, particles, atoms, or molecules. So again, anytime you have to go from mole to something or something to mole, that's always going to be a 1T. And anytime you're going from something to something, that's going to be a 2T. So let's go and talk about how the 3T's will be different. To do a 3T problem, you need to have two items. One is a balanced equation, and two, I have to provide you a given. If you don't have a balanced equation, or I haven't given you a starting item, there's no way to accomplish it. The setup for a triple T is this basic setup here. Whereas before with the 1 and 2 T's, our givens going to go in the far upper left. Your unit to cancel is going to go down here to cancel. Then the only really new step is this step right here. You have to go to the balanced equation. And the balanced equation will basically have numbers, and those numbers will sit in here to basically move from one item to another item. And then just as before, with the double and the single, what we want is going to go on the far right, and the unit to cancel is going to go down below. Now, I know at this point this might be a little confusing, so let's do an actual problem. I think it'll make more sense. Okay, so here's our problem. We have 70 grams of nitrogen. We want to know how many grams of ammonia can we generate, given this balanced equation here of 3 hydrogen plus 1 nitrogen goes to 2 ammonia. I'm going to have this basic setup here. I'm going to show this on the next slide, how to put this together. So first off, my given has to go on the upper left. And my given is this 70 grams of nitrogen. So I'm going to set up 7.0 grams of N2. So that's my given. Then my unit to cancel, I need to get rid of grams of nitrogen. And so I'm going to be going to moles. So 1 mole of N2 is going to be 28.0 grams of nitrogen from the periodic table. So now I'm done that step there, and then grams of nitrogen are going to cancel. Then for the next step, I got to go to my balanced equation. Now I'm starting with nitrogen, and I'm going to ammonia. So I need to look at my balanced equation, and I have nitrogen here. I have 1 nitrogen. That's going to go down here because nitrogen is what we're trying to get rid of. And then I'm going to ammonia, and that's here. So I'm going to have NH3. Now if you notice, there's a 2 in front of the NH3, so I'm going to put a 2 there. So now I can cancel out moles of nitrogen, and now I'm in NH3. Now the question asks, what do we want, which is grams of ammonia? When I look at the periodic table, the molar mass for ammonia is going to be 17.0 grams. 14 for the nitrogen, 3 for the hydrogen. And that's going to be 1 mole of ammonia. So again, the moles of ammonia are going to cancel. So everything cancels across. Grams of nitrogen, moles of nitrogen, moles of nitrogen, moles of ammonia, and now we're left with grams of ammonia. As before, you're going to multiply everything on top and divide everything on bottom to get your answer. So 70 divided by 28 times 2 times 17 gets our answer. On the next slide, it's a more computerized version to show this with the answer. So as you can see in this more nicer format, the answer when you do all that is going to be 85.0 grams as we go across, because we're going to get rid of all these particular items on here to get this to set up. So any triple T problem is going to look just like this example. Given, unit to cancel, got to go with a balanced equation, and then what you're trying to get. All right? Now, if you're still a little bit confused, I would go back and rewatch up to this point. Now what I'm going to do is do 2 additional problems with the same equation, and this is where we're actually going to start on class when we start talking about this topic. All right, so for this problem, we have 90 grams of ammonia. That is going to be my given, 90 grams of ammonia. I need to get rid of ammonia, so for me to get 1 mole of ammonia, I need the molar mass, which is 17.0 grams of ammonia. So we can cancel out that. Then I go to my balanced equation. I'm going from ammonia to nitrogen. Because I have ammonia up here, right here, I'm going to put 2 moles of NH3 down here. That's going to go to 1 mole of N2. Again, all that comes from our balanced equation. Then what's going to happen is I need to go to grams of nitrogen. So 1 mole of N2 is going to be 28.0 grams of nitrogen. So again, I'm going to take 90 divided by 17 divided by 2 times 28. That'll give me my answer. On the next slide is a computerized version of what I've showed here. So again, you can see 90, 17, 2, and 28. 90 divided by 17 divided by 2 times 28 gives me 74.1 grams of nitrogen. All right, let me go ahead and do one more practice problem over this. So for this one, given 85 grams of nitrogen, how many grams of hydrogen can we generate? So I'm going to start with 85 grams of N2, 1 mole of N2 is 28.0 grams. Then I'm going to go to the balanced equation. I have 1 mole of nitrogen. I'm going to hydrogen. I have 3 moles of hydrogen. And then what's going to happen is I'll put 1 mole of H2 on bottom, and the molar mass of hydrogen is 2.0 grams. So again, grams of nitrogen are going to cancel, moles of nitrogen are going to cancel, moles of hydrogen are going to cancel, and now we're left with grams of hydrogen. So slide, here's the finalized version. When you do that, you're going to get 18 grams of hydrogen is going to be your answer. So again, please go through these 3 practice problems. Please come with questions. We'll start up with this next class. The expectation is that you've watched this and have at least understanding, so we can work on this and then start working on our homework that you should be able to get done if you understand this.